Okay, so again, hello everyone. Good afternoon. Firstly, thank you for your time today. So we really appreciate you taking off your busy schedules to join us today. Hence, first and foremost, on behalf of Shimadzu, we would like to welcome you guys to this live webinar on Shimadzu Analytical Solutions to Agri-chemical Analysis. So I am Laika and I am your host for this afternoon. But before we start, let me just brief you guys with some webinar rules. Firstly, this webinar is being recorded, so we will be uploading this in our official YouTube channel. Secondly, all the attendees are required to mute their microphones and turn off their videos all throughout this session, so except for our speaker or later during the Q&A. And finally, you may utilize the Zoom chat box that you are seeing in your screen to type in your concerns and questions. So here's the program outline for this webinar. We'll start with the presentation by our guest speaker, followed by the live Q&A to address your queries or clarifications. And finally, there will be a raffle and prizes are in cash. Yes, in cash. So be sure to stay with us until the end of this session. Also, we will be giving out e-certificates. So later after this, we will be sending you the link to an online feedback form that you have to accomplish first in order to get your e-certificate. So once you accomplish it, I will be sending to you your e-certificate. Okay, so I won't take this too long. Let me now present to you our guest speaker. So to discuss the analytical solutions that Shimadzu can offer when it comes to agri-chemical analysis, it is a great pleasure to introduce to you our speaker, who is none other than Jackie. Yeah, so Jackie without a short name. Yeah, Jackie. So Jackie is actually our product specialist for GC and GCMS as well as for thermal analyzers in Shimadzu Asia Pacific in our regional office in Singapore. So after graduating from the NUS, or the National University of Singapore, Jackie has garnered over 6 years of research, training, and facilitation experience. So Jackie meets scientists from various industries to share technical knowledge and collect feedback, understanding their problems and helping them find the well-suited solutions in GC-related analysis. So without further ado, let's welcome Jackie. Jackie, take it away.
Thank you, Laika. I will do my share screen.
Yeah, sure.
All right. Can you see it in full screen mode right now?
Yes, Jackie, you can see it.
Wonderful. Hi, so good day, everyone. My name is Jackie. Thank you, Laika, for the wonderful introduction. In Shimadzu Asia Pacific, I'm also in charge of the chemical market, and that explains why I'm the person who is giving you this presentation today. So in this presentation, we'll be going through Shimadzu's analytical solutions to agri-chemical analysis. Now, when you look at the term agri-chemical, maybe you will be thinking of certain keywords such as like pesticides or fertilizers, GMO, all these things. What is it truly about? It is always regarding the improving our crop production. So wanting to have more yield and also to make sure that the food that we are consuming is safe. Above that, we also have people who are researching in how to improve the quality of the food that we produce. Just a question, do you see a bar on top? Does it affect you guys when you see my presentation?
No, Jackie, it's completely just your presentation.
Okay, perfect, yeah. Because I see the bar there, okay. Okay, now, whatever is the kind of application that you're looking at in the agri-chemical sectors, all the tests can be performed by using our analytical tools that Shimadzu has provided, because all these tools are the best instruments out there that can help you with calibration. The instruments are highly robust, highly reproducible. So if you want to create any library or to just use any library that has been created and even automation, these are all possible. And so going back to the presentation, our overview, we are going to talk about how to improve research that improves agricultural yield, ensuring safe food, and bettering crops quality. So let's start first with improving agricultural yield. Of course, I'm not a farmer. I'm not very experienced. Maybe I can do some planting in my balcony, but that's all. So at least what I know is that when we want to improve the yield, fertilizers and pesticides will be the most crucial components. Fertilizers provide the nutrients, additional nutrients that will help crops grow more, whereas pesticides prevent pests from consuming these crops. So we want to make sure that whatever that we produce can be harvested at the end of the season. There are so many kinds of pesticides. You name it, we have it. Insecticide, herbicide, fungicide, anything. Whatever you want to kill, it's possible. So this sector of analytical procedure I'm going to share about is mostly involving compounds in very high concentration. So we are talking about, let's say, fertilizer is good quality or our pesticide. So if you are a pesticide manufacturer, you will be more interested in this segment that I'm going to share. So in this first application example, I'm going to show you is identification test of fertilizer by using this FTIR. So fertilizers is now so advanced that we actually have this type of urea isobutyl aldehyde condensate. It is a slow releasing fertilizer complex. So you just place it in the soil and then it will release its nutrients over time, the urea slowly as it reacts with the air and water. And there are certain guidelines on how to measure and identify these kind of fertilizers. So simply by using the FTIR, you can observe the morphology and you can even estimate the quality of the raw materials. So in this example, this is the compound fertilizers we are looking at. The purity score is 0.9937. So of course, in order to get this score, you don't just analyze one run. In fact, you have to perform multiple runs at different time. And this whole thing can be automated. And then it is also very simple because it is non-destructive by using the ATR. So the attenuated total reflection tool, this module that is on the FTIR allows us to have non-destructive analysis of the fertilizer. And this analysis is also very reliable. The report can be generated easily and it gives you the purity score in just a few hours, depending on how long you want to analyze, of course. Then in fertilizers, we are also looking at elemental analysis because when we are supplying nutrients to the plants through the soil, what we are mostly providing are principal macronutrients such as nitrogen, potassium, or phosphorus, even zinc. So the ICP-OES, inductive coupled plasma, optical emission spectroscopy is perfect for such an application. It can be used to identify the elements and at the same time you can quantify them. Whether it is axial or radial mode, it really depends on which element suits better in each mode. However, what you would need to know is that whatever the element is, this instrument will give you excellent linearity. So shown here in an example is the calibration curve of potassium in radial mode. So potassium, for example, is more suitable in the radial view instead of the axial. And we can have very good LOQ over here, as well as recovery, which is not shown in the table over here. But if you would like to know more, we have the application notes to share with you. Now, looking at main component is easy, but what if we want to analyze some of the impurities, such as like a bad nitrogen compound in the fertilizer? So this time around, we are shifting towards a little bit more of the lower concentration compound. So for example, we can analyze nitrous acid and ammonium thiocyanate. These compounds can break down and it will have nitrate and nitrite formation, which will actually inhibit plant growth and it will pollute any water because it is highly soluble. So these kind of compounds are nitrogen containing. We think that nitrogen may be good for the plants, but not all nitrogens are good. And in this case, our HPLC, high performance liquid chromatograph, can be used to do the analysis. It gives you separation of the compounds, excellent linearity, as you will see over here, and also you can have high repeatability, less than 1% RSD, even at 6 repeat runs. So as a result, you can perform quantitation very easily, and you want to find out if a certain fertilizer is good, whether it will contaminate the environment. You can use such instruments to perform the analysis. And then, of course, if you are looking at pesticides, similarly, you are looking at the main component or you are looking at the impurities, we have the right tools for you. For example, we can use multiple GC detectors to analyze pesticides of different functional groups. ECD of the GC is a gas chromatograph. It comes with ECD, which is an electron capture detector that is best for those halogen compounds. So it can be used to analyze organochlorobesticide very well. Whereas the FPD, flame photometric detector, can be used to analyze organophosphor compounds. It can also be used at certain compounds that contain nitrogen. So when you are using this kind of specific detectors, we are eliminating any noise. It cannot see any signal that doesn't contain halogen for ECD or phosphorus for FPD. So the signal becomes very clear, and it will actually improve quantitation quality when you are performing this analysis of specific compounds. So in terms of agri-chemical, we are also very concerned about having safe food. As much as we are using fertilizers and pesticides, we want to make sure that these things don't stay on the food and there is nothing entering the environment and there's nothing from the environment that will contaminate our food. So in this next portion, we will be looking at compounds which are more low concentration. Why do we care so much about these low concentration compounds? Well, food is life. We all eat every day. I mean, some even eat more than 3 times a day. It's normal. But imagine if every food that we eat has this minute amount of pesticides or any kind of contaminants. It will bioaccumulate because it doesn't go away so easily. So the more we eat, the more we will be contaminated and the more we will start having unwanted diseases. You know, COVID alone is bad enough. So there are many kinds of contaminants in the soil which can also get stuck on the food products that we are growing, such as heavy metals or dioxins, phthalates, or polyaromatic hydrocarbons. You name it, there are so many things around in the environment that can enter the food. Therefore, when we are looking at this, there will be specific tools to analyze. And let's start with pesticides. We are commonly using pesticides, and those that are commonly used may retain on the food. And to analyze them, you have to understand that many food are either GC amenable, that means you can access the analysis by GC or by LC. So only around 30% of them can be analyzed by both GC and LC. Now for the non-overlapping, it is easy to identify, it is easy to decide, well, this can only be analyzed by GC and this can only be analyzed by LC. However, for these 30% pesticides, personally, I would recommend using the GC because the results in GC type of analysis tends to be much sharper. So you can consider it like a better resolution television. Like it's just easier to do quantitation. But you definitely will need both tools, that is GC-based and LC-based, to do quantitation of such pesticides. And in terms of pesticide analysis, when it comes to residual level, that means trace amount, I would recommend you to use the mass spectrometer, because MS is a very powerful tool that can help out with complex matrix. I will show you more example later. Complex matrix such as marine products, dairy products, these cannot be easily separated from the pesticides. And then sometimes GC or LC standard detectors alone are not enough to do complete separation. So MS can give you additional dimension in mass for the separation. It is also more specific, more sensitive, similar response to all, so it's easy to quantify all the pesticide at once. And here I introduce to you our UFMS. UFMS is Shimadzu's unique solution. It is ultra-fast mass spectrometer, a MS that is so fast, it doesn't even compromise the system performance at any speed setting. So, you know, when we are saying that we are fast, we are not just fast, we are also good and fast. This is very special to Shimadzu. Just for an example, I can perform an analysis of 420 pesticides in a single run within 30 minutes. So if you remember in an example of ECD earlier, maybe in 30 minutes, we're analyzing 13 compounds. But using an MSMS, we can analyze 420 at the same time in a single run. And each of these peaks, when extracted, is very symmetrical, perfect for quantitation. In fact, the repeatability is so good that the RSD is less than 5%, even though we are analyzing 5 ppb. So it's fantastic. No wonder Shimadzu is given this Frost and Sullivan Award for our proprietary UFMS technology. Because when you can have high-speed performance, you can reduce the runtime and increase the throughput that your lab can perform every single day. And these are all the different MS models that we have in Shimadzu. When it comes to this pesticide analysis, one thing that I need to share is that it is actually, while it is very commonly done, the residual pesticide analysis, it is not so easy. It depends a lot on what is the matrix, the sample matrix that we are looking at. So if I'm analyzing cabbage, for example, it is relatively easier than I'm analyzing in pineapple, because pineapple is highly acidic. Both are watery, but one is acidic, so it just is slightly harder to analyze. And if you compare it to a chili, chili contains oil coloring and also acidity, you know, so it's much harder. So depending on the composition of your food matrix, you will need to select a good solvent for extraction. And after extraction, we also need to perform this thing called cleanup. Because after you extract the pesticides from whatever food matrix that we are looking at, we have to clean up to make sure that there is no additional substances that may be interfering with our results. So for example, if you know that your food matrix contains high sugar or fatty acids, such as the case of pineapple, you have a lot of sugars, then you will want to use the primary and secondary amines for the cleanup. Whereas if your sample tends to be very colored, containing color pigments such as in dragon fruit, the purple dragon fruit, then you would want to use galvanized carbon black. That will remove the coloring. So it will have better results in terms of the repeatability later on. And then we proceed with the instrumental analysis. Shimadzu has your back. So all the way from the sample preparation, talking about extraction and cleanup, to the instrumental analysis, Shimadzu has a complete solution for you. And whether it is any kinds of food metrics, there are a lot of compilation, and we probably have already done such an analysis, and it will help you with your application requirement. Let's look at the example on how we analyze pesticides in GCMS. Remember, half of the pesticides should be analyzed by GCMS? Yes. We have this special database, this smart pesticide database. It comes with basically everything that you need to analyze the pesticides. So it contains information on 530 pesticides, which are mostly regulated in the world right now. And you have functions that will allow you to create method automatically. You can adjust the method. You have total solution from the standard, the pretreatment kit to the consumables. So it's basically you just plug and play. And of course, you are supposed to get the individual pesticide standards if you want to perform accurate quantitation. And we also have libraries that help you to identify these regulated pesticides. So these pesticides will also come with additional information such as retention index that can help you identify the compounds better. We even have the negative chemical ionization mode. So here is the example. The determination of pesticide residue in chili. Now, as I mentioned earlier, chili has coloring, it has oil, it has acidity. So it is actually a really, really tough sample matrix. And in order to perform this analysis, proper question extraction and also the cleanup procedure will be necessary. And we use GCMS MS because it can give you a very good linearity as well as recovery. You might think that these numbers are rather bad. In fact, it is not. While most of the time we are looking at R squared that is more than 0.99, it is a very tough sample matrix. So a 0.985 for all the pesticides is actually a fantastic result. And all the repeatability is within 15%, whereas the recovery is 70 to 120%. We also have similar method package for the LCMS. So just like the GCMS, now we have the method package for LCMS, which is plug and play. It contains high-speed simultaneous analysis method for 646 pesticides. And it has all the compounds which are covered by the different regulatory bodies. So here is the analysis when I'm looking at 646 pesticide residue in mean extract. And this can be done within 10.5 minutes. Excuse me, let me drink water. While this sinks in. So if you look at this, this is the incredibility of using an ultra-fast MS. Everything just comes out super quickly, and you can definitely perform more analysis. When we zoom in specifically at this range, where we actually have 25 different compounds overlapping, you can see that each of them is actually very highly symmetrical, and it is great peak shape. Great peak shapes will allow us to perform better quantitation, higher linearity, and better repeatability. Now, on top of analyzing residual pesticides in food, you might also be concerned about the pesticides used entering the environment, such as the analysis of acephate. Acephate is a highly soluble pesticide. So it will actually, when you pour it onto the soil, it will enter the groundwater, and if there's rain, it will be worse. And in order to analyze acephate, which is an environmental hazard, we have to use the special extraction by using porous diatomaceous earth. This is a special compound that is used because it will have a recovery of nearly 100%. And in this case, we actually use GCMS, just single quote is sufficient for identification and quantitation, down to 0.037 microgram per milliliter. So this is very good result, 37 ppb. There are also many other environmental concerns, such as the TAH, or even if you are looking at dioxins. Then dioxins are a kind of this persistent organic pollutant. It will never go away. The half-life of it is probably like 7 years. So as you have more and more dioxin, it will just accumulate in our bodies. And how many 7 years do we have? So it is a very concerning compound, honestly, in terms of food safety. And to quantify the dioxin in our animal feed and food, there is a standard method that is being governed by the EU, the Eurozone. And this is at a very, very crucial, very critically low concentration limit. For example, at 0.1 nanogram per milliliter. So that is low ppb level. Now we can still perform the analysis very well using our GCMS triple quadruple system, and we even used it to analyze a positive sample. So I am obliged to not share where this place is, but it was an egg sample and have performed the analysis myself. So it was quite concerning when I found that while the regulation says the total amount of dioxin should be no more than 1.5 nanogram per kilogram, we actually found 48. So, this is a really very severe case, and therefore we reported to the authority, and then they decided to not use that batch of egg. Yeah, but it's not Singapore, it's just somewhere around ASEAN countries, not Philippines also. Then we are also concerned about heavy metals. Heavy metals are easily also entering the water system, entering our food. So while nitrogen, potassium, phosphorus, these can be very good macronutrients, we are also concerned about the toxic elements. Now, these are the micro ones that are actually very dangerous to the human bodies. For example, cadmium, lead, mercury, and our AAS, atomic absorption spectroscopy, which is a partner to our ICP OAS, you can use either one to perform such analyses. Our AAS actually comes with flame or electrothermal modes, and both modes are actually very good in terms of performing the analysis. So in this, I'm showing you the calibration curve in the electrothermal mode. When we want to meet the regulation, which is stated for the pet food, the amount of cadmium permitted is 1 ppm, whereas for lead, it is 3 ppm. So either mode actually give us very good result and fantastic limit of quantitation. So when you have to perform such analysis, know that Shimadzu has all the solutions for your requirement. Now, moving on to the last part, we are going to talk about how to study the research that will help bettering the crop's quality. So one of these recent concerns is about GMO, genetically modified organisms. The testing and analysis of GMO can also be done from Shimadzu's instrument. Over here, we have this Multina. Multina is a kind of instrument that is combining the power of PCR and also gel imaging. So over here, we are performing an analysis of this MON810 DNA in modified corn. Now, in terms of this analysis, we have to do some DNA extraction, and then we have to perform PCR, and finally do the electrophoretic analysis by Multina. And from the results here, this is a gel image that you can see. On the left side, from sample number 1 to 12, these are checking for endogenous corn gene, SSIIB3. So you can see that this is engineered corn gene, and number 1 to 9 all contain the same gene. So they are all really corn. Whereas sample number 12, which is a positive control that we have planted in, must definitely also have this gene. So 10, 11 doesn't have it, means they are negative because these are negative controls. And then we repeat the analysis, now looking for the MON810 DNA, which is around 131. And so this modified gene, you will notice, you can observe it on number 12. Of course, it is our positive sample, our positive control, sorry. Now from samples now, number 1 to 9, you can actually find the modified gene only in number 4 to 9. Yes, because these are actually known to be 1% GMO or 5% GMO. So using this instrument, you can actually perform analysis if you already know which gene you are looking for. And then in terms of some food quality research, you may also be wanting to look at the metabolites. Now, Shimadzu has another database that can be used in this requirement. We have the Smart Metabolites database version 2 for GCMS, containing 475 metabolites. So same thing, it can help you create more method automatically. It also comes with total solution with recommended standards, pretreatment workflow, and consumables. So in terms of like, in this example, I'm showing you an analysis of tomato. So in the plant metabolome analysis, we actually can associate certain metabolites to why it has certain color, flavor, fragrance, or any other qualities. And using the GCMS, we can now use it not just for quantitation, but also for targeted screening. The term targeted screening is a little bit unusual because it might be counterintuitive. If you are familiar with the instrument, you would know that GCMS, LCMS, these are quantitative tools. But because it uses this special mode called MRM, the multiple reaction monitoring mode, where you can analyze certain compounds that has a specific parent ion to product ion, parent ion to daughter ion, or precursor ion to product ion. So This transition from the parent to the daughter is actually really specific. And when you can identify multiple MRMs, you can use it to identify certainly if a certain compound is present. Now, using this type of reverse way, we can identify which metabolites are present in this particular sample, and we can actually associate it to the different characteristics of our plant. So it is usually studied using multivariate tools and many other things that you can add in, like the studying the cycle, you know, that kind of workflow thing. Yes. So in this example, when we want to do quality evaluation, I have 3 different tomato samples. And after deconvoluting all the pigs, detecting the pig, doing library search, aligning them, then we can tabulate them and perform a PCA analysis, principal component analysis, where you can see multiple types of tomato comes in different areas. So that is why they are associated to different characteristics. If you want to know why, you have to look at the loading plots. What are the compounds associated with them? You can also do this hierarchical clustering analysis to have some idea of how the characteristics may be different from each other. And of course, every research is different. So just know that Shimadzu has the tool for these applications. And not forgetting that whatever we are doing in terms of agri-chemical analysis, whether it is improving crop quality, improving the yield, ensuring the food is safe, many a time we are very concerned about how our data can be stored accurately and authentically. So we want to make sure that there's nothing that is breaching the integrity of our results. And therefore, hereby, I will introduce you our data integrity solutions using our informatics tools. Our informatics tool, particularly the Lab Solutions CS, comes with authorized access, electronic controls, record retention, and electronic signatures. So this kind of thing will make sure that your data is fully accountable. You can even report it to any organization that you may want to report to. Populating all the information that you need, maintaining the SOPs that your company does. And it is not just this lab solution CS that we are looking at. We are actually giving you total data integrity solutions for the entire lab. So whether it is about a dashboard, e-dashboard, or when you want to combine multiple instruments into the same network system, about LIMS, the total lab instrument management system, Shimadzu has it for you. And so here is a summary of all the solutions that we have for agri-chemical testing. And I hope you have enjoyed the presentation and learned something from my sharing. Thank you for your attention. Laika.
All right, so thank you, Jackie. Definitely, everyone here has learned a lot with regards to the Shimadzu Analytical solutions in agri-chemical analysis. So it's very overwhelming that we have various technologies. So not only with the instruments, but also in terms of data management. Yeah. So let me just share my screen. Okay. So with that, we can proceed with the Q&A. So if you have any question, please feel free to message us or publicly or privately. And if you want to talk with our speaker, please feel free to do so. Just type your name in the chat box and company name, and we will give the floor to you. Okay. So I have gathered here a few questions already. Yeah, but you can still type yours in the chat box. So let's start with the first question. Okay. First question is, what is the difference of UFMS with a normal MS? Is it different from single quadruple or triple quadruple MS? Good question. Yeah.
Okay. Thank you for the question. I was worried there was no question for me. Okay, so anyway, UFMS and MS. Actually, UFMS is still a mass spectrometer. You know, it's like everybody has an MS, every vendor. But Shimadzu's MS has this special ability of not compromising in the performance. Well, for example, just look at GCMS, single quadruple and triple quadruple. This is an example. Many other vendors, when they are shifting the technology from single quadruple to triple quadruple, the basic functions may have been lost to compromise so that they can have that good quantitation ability in triple quadruple. But we know that when we are using a GCMS MS, sometimes you may just want to do the single quad functions, like the sim mode or the scan mode. Now, if you are using other normal MS, then you may have lost some ability on it. Even though you can do it, it's not just so good. But with UFMS, everything is ultra fast because we pride ourselves with our hardware. Shimadzu is a Japanese company, and Japanese people are very meticulous and very careful about this technical hardware thingy. So it's always make sure that whatever that was good will be inherited in our new instruments and nothing will be lost in terms of performance. So when you want to compare UFMS and MS, well, I'll just say that we are above the rest.
Okay, very well said, David. Sorry, Jackie. Yeah. So for the next question, so this is with regards to residual pesticide analysis. Yeah. So can you give recommendations on efficient purification of residual pesticides in fruits and vegetables? Yeah.
Can you repeat the question? At purification?
Yeah. Can you give recommendations on efficient purification of residual pesticides in fruits and vegetables?
So that means purifying the pesticides?
Yeah, maybe that's her question.
That is an interesting question. So in our usual workflow, what we do is we homogenize our sample, whether it is fruit or vegetable, we will just homogenize it and we will extract the pesticides out. So we hardly purify because when we are doing the extraction, what we are doing is sort of like purifying, but we are taking it out and separating it from whatever that may be interfering with our analysis. So the act of extraction could just mean the purification they are talking about. Traditionally, people do liquid extraction. As a chemist, I'm sure everyone here has done it before, like release the gas, shake, release the gas. Now, this procedure has been simplified so much and miniaturized to just the simple quenchers. So what you do is to add solvents such as acetone and nitrile and then shake into the salt. And then after that, ta-da, you just need to clean it up, removing any more interference. So I think when you're talking about purification, I suppose it is the quenchers that is very popular in the modern world where we are doing simple extraction and cleanup quenchers. You want to know more? We have the tools. Depending on your food sample, we have the different quenchers kit to perform such analysis.
Okay, so in relation to that question, so somebody asked, do I still need sample preparation for irrigation water in analyzing residual pesticides? Yeah.
Yes. The answer is yes. So the thing about whenever we are dealing with residual compounds, right, that means they are in trace level. So even though our instruments are powerful, you have to feed the right thing for it to generate the right data. Hold on. Sorry. Yeah. Even if you are looking at irrigation water, the amount of pesticides that will be inside is not going to be like, 2%. No, we are looking at maybe 2 ppb, 2 parts per billion. And that means you will, in order to make it visible, you will have to inject 100% of water, then you will have 2 parts per billion of pesticide. That is too difficult to analyze. Therefore, extraction and cleanup is a standard procedure when we are analyzing anything at very trace amount.
Yeah, okay, if I may add, yeah, so sample preparation is really necessary. Yeah, of course, to obtain a high sensitive results, yeah, especially for trace level analysis. Yeah, okay, so for the next question, yeah, so if the tested sample is found to be hazardous, do you provide possible solutions as well?
Is found to be which compound?
Hazardous. If the sample is in nature is hazardous. So the question is, do you provide possible solutions as well?
Azaratu, what is that?
Hazardous. Hazardous.
Hazardous.
Yeah.
Hazardous. Okay. Sorry. Different accent. Don't worry.
Yeah.
English is not our first languages. So if the compound is hazardous, will we? What was the question?
Do you provide, where is this? Possible solutions as well.
Okay, sorry. I was too focused on the word hazardous. Yes, so whichever compound that you may be looking at, we probably already have a solution for it. So in this presentation, I only showed some of the examples, like when we are looking at dioxin, when we are looking at pesticides. But in actual, we actually also analyze things like brominated flame retardants, phthalic esters, I cannot name so many things, like, anything that sounds hazardous, organotin, or I don't know, so many of them. It's endless. The list of things that we are analyzing is endless. But whatever you're analyzing, Shimadzu probably already has a solution for it. So feel free to check out with our sales representative.
Yeah, so just what like Jackie said, so just provide your target analytes, and definitely we will provide you the most suitable solution or appropriate instrument for that. Okay, questions are keep coming up. So let's proceed to the next question. So may I ask, in untargeted plant metabolomic analysis, how do you deal with novel metabolites that are not in the library?
Fantastic question. What I have shown you was only targeted screening. So GCMS, MS, LCMS, MS, those are possible for targeted screening. Now, this question is asking about things which are not known yet. So it's not possible to target them. And therefore, we are doing unknown screening, untargeted. We just want to screen everything. And we, in fact, do have this kind of instruments. This is also an MS, a mass spectrometer that is high resolution, the real high-res MS, which can analyze compounds down to like 4 decimal places. So when you have a mass that is like 4 decimal places, you can have a very good idea of what the empirical formula of this compound is. And I'm talking about the instrument called QTOF, a time-of-flight instrument. When you have this kind of resolution, you know the empirical formula, you have an idea, you can perform additional analysis to try to figure out what the structure is. And that will help us to identify the compound. And of course, QTOF is not just for that. You can also perform quantitation with it. So no matter what is the compound, no matter what you are trying to analyze, we have a solution for you. Yay, surprise.
Yeah, okay, so that's great, Jackie. Yeah, okay. So in relation to that, so same person asked, so how do you usually derivatize samples for GCMS for plant metabolomic analysis?
Even though I briefly mentioned it was already recommended in the Smart Metabolite database, so generally what we do is to perform a TMS, trimethyl silyl group derivatization. So the person who has done this, who asked this question must have done this application before, because actually the compounds we are looking at, like fatty acids, amino acids, sugars, these are not compatible with GCMS by default. We have to perform derivatization and change the functional group so that the labile protons, the OH, the NH, the COOH, or the H can be replaced with something else. We can replace it with TMS group. We also can replace it with TFA group. These are all inside the database. Yeah, so these are the recommended way of derivatization.
Okay, so for the next question, let me answer this question. So does Shimadzu still manufacture or sell conventional GC or LC? Thank you. Yes, we still offer in Shimadzu Philippines the normal GC and LC. So that those are units without the MS detector. Yeah. Okay, and for our final question. Okay, where is it? Yeah. Do you have a way to analyze natural insect repellent? I am researching on the use of pH.
Okay.
Yeah.
I have heard of one customer from Philippines, in fact, who is analyzing this natural insect repellent. But I think this group was using pheromones. So if it is pheromones, we have this kind of analysis, like to collect the pheromones from the nature, to condense it, so as to purify, but not to purify, mainly to pre-concentrate it, then analyze it using the GCMS or LCMS. And then if you are talking about pH, it's possible. Well, if you are studying only pH, then you only need a pH meter. But if you are looking at a compound, specific chemical compounds, we have the solutions for you. Yes, I hope this answers the question.
Okay, so that's it for the Q&A. So guys, if you still have questions, so please feel free to send us a message, send us an email, so even Jackie. Yeah. Okay, so with that, thank you so much, Jackie, for being with us today. So it is a great opportunity to have you discuss some of the technologies that we can offer for the agri-chemical analysis. So we have a number of technologies, recent advancement, instruments. So all you have to do, guys, is just send us an email, one call away, one text away, and we will be providing you the most suitable solutions for that. Okay, so Jackie, again, thank you, and we hope to see you again next time. Okay, so for more Shimadzu webinars, you can access those in Shimadzu digital classrooms, wherein Shimadzu now allows you to learn at your own pace and convenience, anytime, anywhere. Why? Because this Shimadzu digital classroom is equipped, so it is an innovative tool that is packed with Shimadzu webinars, both live and recorded on various analytical technologies, applications, solutions, flow of information, and compliance. So to look for Shimadzu Digital Classroom, just type in the Google Shimadzu Digital Classroom, and there you will be directed to that. Okay? And for more information regarding Shimadzu products and services, just visit our official LinkedIn and Facebook pages, and feel free to send us a message if you have any inquiry. So just search Shimadzu Philippines. And just this year, we launched our YouTube channel. You may subscribe, please, and watch a number of videos featuring Shimadzu products and applications. And actually, some of our webinar recordings are already uploaded there, and more updates are yet to come. So this marks the end of our session for today. Thank you everyone for participating, and we look forward to your usual support in our succeeding webinars and other marketing activities posted in our social media platforms I've mentioned a while ago. So thank you again, and enjoy the rest of the day. So keep safe everyone, please, and bye. Yeah. So see you in our next webinar.
Excellence in science. Shimadzu.